Okay, here's a strange one for you. What could the billion-year history of ice ages possibly have in common with growing your money?
Huh. It sounds completely unrelated, I know.
Right, like a
But,
trick question, but apparently the answer tells us something really fundamental about compounding.
exactly. That's what we're digging into today. This incredible and often really counterintuitive power of compounding. We're going to pull lessons from these, yeah, seemingly very different fields.
Okay, so what's the mission here?
The mission is to show you these extraordinary results. Results that, honestly, our brains are just not wired to predict easily.
Logic-defying results, it says here. I like that. We're looking at sources connecting geology and finance.
That's the plan.
Yeah.
Unpacking these hidden drivers of success that often get missed because they don't seem dramatic enough at the start.
All right, let's do it. Where do we begin? Ice ages.
Yeah, let's start there. And it's kind of amazing how recently we even figured out the basics about our own planet. Isaac Newton understood stars centuries before we really grasped Earth's geology.
That is wild. So ice ages weren't always accepted science.
Not at all.
Yeah.
It really wasn't until the 19th century that the scientific community generally agreed, okay, yes, the Earth has gone through multiple ice ages. Not just one, but 5 distinct ones.
And what finally convinced them?
The evidence just piled up. Things like massive boulders just sitting in fields miles from any similar rock formations, or huge areas of bedrock scraped totally smooth down to thin layers, things that only continent-sized glaciers could really explain.
Okay, so the evidence becomes overwhelming. 5 ice ages.
Right, and then you think about the energy involved. I mean, the sheer staggering amount of energy needed to freeze huge parts of the planet, then melt it all, then freeze it again multiple times.
Yeah, that's immense. So naturally, they thought it must be some huge cataclysmic event causing it, right?
Precisely. The first theories were grand, like maybe huge mountain ranges suddenly uplifted, changing weather patterns, or massive, prolonged volcanic eruptions blocking out the sun. They were looking for a cause that matched the scale of the effect.
But those theories didn't quite work out.
They hit a wall, basically, because none of them could properly explain why it was cyclical. Why did it happen over and over again, these freeze-thaw cycles?
Ah, the repeatability. Okay, so the big dramatic events weren't cutting it.
Exactly. And that's where this Serbian scientist, Milutin Milankovic, came in back in the 1920s. His theory was the breakthrough, and it was surprisingly gentle.
Gentle. How so?
He proposed it was down to the subtle gravitational pulls of the sun and the moon, just slightly tweaking Earth's orbit, its tilt, its wobble over tens of thousands of years.
Okay. I can see how that might change things gradually, but enough to cause an ice age.
Well, these tiny changes alter how much solar radiation hits different parts of the Earth at different times of the year. It's a very slow, gradual shift in sunlight distribution.
Right, so the thinking was these shifts must make winters incredibly cold, triggering a freeze. That feels intuitive.
That was Milankovic's initial thought, too. Makes sense, right? Colder winters, more ice. But then this Russian meteorologist, Vladimir Kopin, he dove into the actual climate data associated with these orbital cycles, and he found something completely counterintuitive. The real driver wasn't brutally cold winters. It was moderately cool summers.
Wait, cool summers? That sounds underwhelming. How does a slightly cooler summer cause a planet-wide deep freeze?
I know, it feels wrong, doesn't it? But think it through. A summer that's just cool enough that not all the previous winter's snow melts away. What does that leave?
A little bit of leftover snow or ice?
Exactly.
Yeah.
A small, lingering base of snow and ice. Now, that leftover patch makes it easier for more snow to accumulate the next winter. It provides a foundation.
Okay.
Then the next summer, because you started with more snow, it's even less likely to melt completely, so you get slightly more leftover snow.
I see where this is going.
Right. And that slightly bigger snow patch reflects more sunlight back into space than bare ground would, which causes a little bit more local cooling.
Making it even easier for snow to stick around the next year.
You got it. More snow accumulation, higher chance of surviving the summer, reflects more sun, causes more cooling, leads to more snowfall. It feeds back on itself. It compounds.
So it's a snowball effect, literally.
Literally. And this process, starting from just one slightly cool summer leaving a thin snowpack, can escalate remarkably quickly in geological terms. We're talking maybe just a few hundred years to go from that first persistent snow to a continental ice sheet miles thick.
Wow, not a sudden snap, but a runaway accumulation.
Exactly. And the reverse process works too. with slightly warmer summers eventually managing to melt more than accumulates each year. It just shows how something utterly massive can grow from a relatively tiny change in conditions, a starting base that seems almost insignificant.
That's a powerful example of results seeming to defy the logic of the initial cause.
It really is.
Yeah.
And that core lesson, this massive result from a small starting point, amplified over time, it applies directly, almost spookily well, to how serious wealth is often built.
Okay, connecting the dots to finance. This is where Warren Buffett comes in, right? You mentioned over 2,000 books on him.
Yeah, thousands of books picking apart his brain, his strategy, his quotes. And look, a lot of them are great, very insightful.
Yeah.
But they often miss the simplest, most dominant factor. His fortune isn't just because he's a brilliant investor. It's because he's been a brilliant investor for pretty much his entire life, since he was a kid.
3/4 of a century, the source mentioned.
Think about that.
Yeah.
75 years of compounding. Let's look at the numbers. They're kind of mind-blowing.
Yeah.
His net worth, around $84.5 billion when the source was written.
Okay, huge number.
Now get this, $84.2 billion of that. Almost all of it was accumulated after his 50th birthday.
After 50, wow.
And it gets better.
Yeah.
$81.5 billion came after he was in his mid-60s, already eligible for Social Security.
That's actually unbelievable. So he's great at investing, sure, but the real magic ingredient is just time.
It's the crucial multiplier. He found a good strategy, a high rate of return, relatively speaking, and just stuck with it for an unprecedentedly long time.
Let's try that thought experiment you mentioned. Make it concrete.
Oh, okay. So Buffett started investing super young, around age 10. By age 30, he already had $1 million, which is like $9.3 million today, adjusted for inflation.
Which is already impressive at 30.
Totally. But let's imagine a more typical path. What if he, spent his 20s figuring things out, maybe traveled, went to school longer, and let's say by 30, he had a more modest but still respectable $25,000 saved up.
Right.
And then let's say he invested that $25,000 and achieved the same fantastic annual returns Buffett did. But he decides to retire at 60, like many people aim to. Play some golf, travel.
Right. So starts later, finishes earlier, same great investing skill in between. What's the outcome?
His net worth wouldn't be $84.5 billion. It would be, according to the calculation, around $11.9 million.
11.9 million. Compared to 84 billion.
Yep. That's 99.9% less. Just from starting later and stopping earlier, even with world-class returns in the middle.
Okay, that drives the point home hard. His skill is investing.
But his secret is time. That's compounding running wild over decades.
And there's that comparison with Jim Simons, right? The hedge fund guy.
Ah, yes, Jim Simons from Renaissance Technologies.
Yeah.
This makes the point even clearer, I think. Simons has achieved returns that are just astronomical. Around 66% per year since 1988.
66% a year. That's insane. Buffett's around 22%, right?
Roughly, yeah.
Yeah.
So your intuition immediately says Simons must be vastly richer. He's clearly the better investor on an annual return basis.
Yeah, stands to reason.
But he's not. Simons' net worth is estimated around $21 billion, which is incredible, obviously, but it's about 75% less than Buffett's $84.5 billion.
75% less, even with triple the annual return. How?
Time again. Simons didn't really hit his investing stride. Didn't start Renaissance until he was 50 years old.
Ah, so he had less than half the time to compound compared to Buffett.
Exactly. Less than half the runway for those amazing returns to multiply. And just to show how crazy compounding gets, if Simons had somehow managed his 66% annual return for the full 70-year period Buffett has been investing.
Uh-oh, I feel a ridiculous number coming.
You brace yourself. He'd be worth $63 quintillion.
Okay, that's just meaningless monopoly money territory. 63 with 18 zeros.
Pretty much. It's an impractical, absurd number, but it highlights the core idea perfectly. Seemingly small changes in growth assumptions, or, critically, the time you allow for growth, lead to these utterly mind-boggling outcomes.
And because the outcomes can seem so crazy, we maybe don't focus enough on the inputs, like time.
I think that's exactly it. We dismiss the results as unrealistic, so we overlook the simple, powerful drivers like duration or like the cool summers causing ice ages.
Which brings us back to why this stuff feels so counterintuitive. Why does compounding surprise us?
Well, it boils down to how our brains work. We think linearly, much more naturally than we think exponentially. Meaning, if I ask you to calculate 8 plus 8 plus 8 9 times in a row, you can do that pretty quickly in your head. It's 72, simple addition.
Right.
But if I ask you to calculate 8 times 8, 8 times 8, 9 times, 8 to the power of 9.
No chance. That's calculator time.
Exactly. It's 134,217,728. It's a completely different beast. Our intuition isn't built for that kind of rapid multiplication, that exponential explosion.
Yeah, definitely not. That hard drive example really clicked for me too. We just never seem to anticipate how fast things can scale up.
It's a fantastic illustration. IBM's first hard drive in the 50s held maybe 3.5 megabytes. Huge thing, cost a fortune.
Right.
By the early 90s, a typical PC might have, 200, maybe 500 megabytes? A decent jump.
Seems like a lot then.
It did. But then, whoosh, the curve went vertical. Think about the numbers. From 1950 to 1990, about 40 years, we gained maybe 300 megabytes or so of typical storage. From 1990 to today, roughly 30 years, we gained, drives are measured in terabytes now. That's millions of megabytes.
Yep.
We probably gained 100 million megabytes in that shorter time frame.
30 million times more storage. It's hard to even get your head around that kind of change.
It is. And who in 1990 would have realistically predicted that? It shows how even very smart people can get caught out by exponential growth.
Like the Bill Gates example with Gmail.
Yeah, that's a classic. Back in 2004, when Gmail launched, offering a whole gigabyte of storage for free, which was revolutionary then.
I remember that. It seemed impossibly generous.
Right, and Bill Gates publicly questioned it, wondering why anyone would need that much space. His thinking, even as arguably the most influential person in tech, was still kind of anchored in that old world where storage was scarce and had to be carefully managed.
He just didn't see the exponential trend continuing at that pace for storage.
It seems not, at least in that moment.
Mm-hmm.
And it highlights the danger. When compounding isn't intuitive, we tend to just ignore its potential. We try to solve problems or achieve goals using more linear brute force methods.
Not because we're necessarily overthinking, but because that exponential growth lever isn't even really on our radar.
Precisely. It's why, go back to Buffett, you have 2,000 books analyzing his stock picks, but very few are simply titled, "This guy just kept going for 75 years."
Huh. Yeah, that book could be short.
Maybe the most powerful investing book could just be one page, titled, "Shut Up and Wait." And the only content is a long-term chart of economic growth or a market index.
Simple, but maybe the most profound advice.
It speaks volumes about the power of time and just letting compounding do its work.
So the big takeaway for you listening, this difficulty we have in intuitively grasping compounding, it's probably behind a lot of failed investment strategies, isn't it?
I strongly suspect so. We chase the highest possible returns year to year because that feels like the fastest path to wealth. It's linear thinking, more return equals more money, faster.
But that often involves taking huge risks or strategies that are hard to stick with.
Exactly. Maybe you hit big one year, but then you blow up the next. Or the strategy is so complex you can't maintain it. Good investing, the kind that builds serious wealth over time, often isn't about those absolute highest returns. It's about getting pretty good returns. Returns that are decent, maybe not spectacular, but crucially, returns that you can stick with. Returns generated by a strategy you understand and can repeat consistently for the longest possible period of time.
Because that's when the compounding really takes over.
That's when it runs wild. Patience becomes the superpower, not just aggression or complexity.
Okay. So reflecting on all this, the ice ages shaped by cool summers, compounding over centuries, fortunes built by consistent effort, compounding over decades. It really emphasizes longevity and steady, repeatable action.
It does, across vastly different scales.
So here's a final thought for you to consider. Knowing this, knowing the profound impact of time and consistent effort, how might that change how you approach your own long-term goals, whether that's financial, professional, maybe even personal learning or health? How does reevaluating the power of just sticking with something, even if the initial steps seem small, shift your perspective on what it takes to achieve something truly significant, something to mull over?